This video is sponsored by Squarespace. Whether you're building a professional website for your business or you simply want to build a blog to track the progress of your hot rod build, Squarespace has the tools to make it easy. Today we're getting back to work on the 396 with resizing the connecting rods with a set of ARP rod bolts. The old rod bolts have already been removed from this set of rods and they've been baked and shot blast clean. Before doing any machine work, we give them a quick once over to check for any signs of damage like a spun bearing before filing flat any raised edges that will interfere with machining later on. This connecting rod is experiencing cycle after cycle of compression and tension as the piston is going up and down in the cylinder. And even with your rod bearing in there over hundreds of thousands of miles, this bore is actually going to get distorted. And that's why we choose to recondition the rods. So the way we do that is take the mating surface here of the connecting rod and we can grind material off of the rod as well as the cap. So by grinding that material off, we actually bring the diameter back down tighter than is originally called for. At that point, we take it back over to the rod hone and we hone the material out until we're at the correct dimension. Our rod and cap grinder is set up with a CBN grinding wheel. With the wheel backed off and one of our caps clamped in the machine, we can slowly feed the wheel up until we just hear it contact the surface of the cap. At that point, we can raise the wheel a few additional marks on the dial, corresponding to a few thousandths of an inch. On the grinder, a steel rod locates the face of the cap relative to the wheel, while the clamping mechanism is tightened down. The cap is then swept back and forth across the grinding wheel until the cap sparks out, at which point no additional material is being removed. The end result should be a cleanly machined mating surface. The process is similar on the mating surface of the connecting rod. However, in our shop, we cut the rod with a very slight inward angle with a feeler gauge under one side. When the rod is assembled later on, this slight angle pulls the sides of the rod inward, decreasing the diameter so that we can hone it out to size later on. With the rods and the caps all ground, there's usually a pretty sharp edge left that can damage the rod bearings during installation, so we quickly chamfer the edge on a belt sander. At this point, our connecting rods are fully prepped for the new rod bolts. While this build is only going to be a small step above stock, the ARP rod bolts give us that extra peace of mind. Before we get those bolts installed, I wanted to tell you about our sponsor for this video, Squarespace, who we have had a website with since 2015. When it came time to build our shop's website, we didn't have the resources to hire a professional web designer, but you simply don't need one with Squarespace. Their site builder makes it easy to make a professional site, especially with the various included pre-built layouts. Since we all know that the younger generation can't do anything without their phones these days, it's important for your site to look good on a mobile device. And Squarespace automatically includes a unique mobile experience with each template. One of the analytics panels that I love with Squarespace is the geography panel, because it lets me see exactly where our website's visits are coming from, all the way down to the exact city. So head on over to squarespace.com for a free trial, and when you're ready, go to squarespace.com/JimsAutomotive and use discount code JimsAutomotive to save 10% off a new domain or website. The ARP bolts we're installing are a press fit into the connecting rods, and the provided sheet gives instructions on the recommended torque or stretch specifications. I like to use a little bit of the provided Ultra Torque assembly lubricant on the bolts themselves before starting them into the rod with a rubber hammer. While you could go ahead and drive them into place with a hammer, we don't like to leave marks all over the head of the bolts, so instead we press them into place with the help of our bench vise, which does take more time, but it's more controlled and eliminates most of the risk of damage. With all of the rod bolts installed, it's time to match the caps up to the proper rod and get the rod nuts installed and torqued to spec. Even though we're resizing the connecting rods, it's still critical to start with the correct cap that the rod had from the factory. Luckily in this case, the caps and rods are correctly numbered, so matching them up was a breeze. If for whatever reason your caps do get mixed up, You can usually find the correct cap by comparing the chamfers on each edge, as well as the fit until you find a match. We'll use the provided lubricant on the threads of each bolt, as well as under the flange of the rod nuts to improve the likelihood of consistent torque values. That being said, the torque values can be wildly inconsistent, so ARP recommends measuring the stretch of your rod bolts to verify proper clamping load. By measuring the bolts before and after torquing them down, you can verify that your stretch is within the specified values. In general, once you verify the value on the first couple of bolts, you can go ahead and note the required torque value to achieve that stretch and torque the rest of your bolts to that value. With all of the caps torqued onto the rods, we'll give the faces a quick touch on the belt sander to remove any final burrs, and then we can move over to the connecting rod hone to get ready to finish out our rods. We'll first set up our precision bore gauge to the factory diameter tolerance, allowing us to verify that after grinding the rods and caps, our connecting rods are a few thousandths of an inch too tight. Next, we need to set up our machine for honing, starting with verifying that our speed is set correctly for the proper diameter based on the chart on the machine. Turns out, the machine is already on the correct pulley. The next step in the process is to choose the proper size honing mandrel. The proper mandrel for this size is labeled for above 2.400 or below 2.400, so we'll set it for the below 2.400. The next lower mandrel is a 2.200, which would be too small for these rods. With the mandrel installed in the machine, we'll next be setting up the power stroke feature so that we don't have to stroke the rods by hand. This starts with the guide rings, which again must be chosen based on the diameter of the connecting rods, so we've chosen the rings labeled 2.3 to 2.4 inches. We now need to adjust the attachment for the width of the connecting rods, since they do not currently fit between the guide rings. We'll loosen the 3 nuts holding on the front guide and slip the connecting rod into place over the mandrel. While holding the guide tight to the rod, we'll lightly tighten the bolts until they just hit the guide before backing them off one flat and tightening down from the opposite side. There is an additional adjustment for the stroke length, but it's already set to the correct length. We do, however, need to adjust the position of the power stroke attachment such that the connecting rod will overstroke the same distance on either side of the stone, which not only helps the rod hone evenly, but also helps the honing stones wear evenly. The final step in setting up the machine is to adjust the brass guide shoes to the curvature of the connecting rod. This is done by positioning the rod over the honing mandrel, loosening the screws on the guide shoes, applying pressure against the rod with the hone, and tapping back and forth on the rod. This allows the shoes to roughly position themselves relative to the curvature of the rod before lightly tightening them back down. We'll begin the honing process with a roughing stone, which removes material quickly, but leaves a more imperfect surface finish.
Here's one of our rods that we haven't done any honing on yet. It's at about 3 thousandths there. Tapers down to about 1.5 thousandths. So we want to aim for between 0 and 5 of the little marks past, because that would be a 0.5 thousandths. We basically have a 0.5 thousandth tolerance on these. I'm going to do 8 strokes on that side. Flip the rod around. 1, 2, 3, 4, 5, 6, 7, 8. So now we've brought it down to about 2. There we've got about 1 thousandth, and you can see now we're round. The needle isn't changing no matter where we're at, really. Maybe a little bit at the parting line, but not like it was before. A few tenths more. We're about 3/10 from our finished size, from our minimum finished size, rather.
I like to bring all of the connecting rods to within a few tenths of the tight side of our specification with the roughing stone, before changing over to our finished stone, which is a finer grit. The finished stone leaves a nicer finish with better bore geometry, but takes longer to remove material and the stone breaks down more quickly. I also lower the pressure on the stone, which again slows the material removal process, but allows you to be more precise and accurate with your final size. Right now while I'm working?
Hey, you're making a mess. I gotta get this place cleaned up.
Turn the pressure down. Let's go ahead and check all 8 rods now that we're done. Our tolerance is 2.3247 inches to 2.3252 inches. So I've got our micrometer here set to the small side, 2.3247. Double check our gauge here, and we're right on 0 there. We can be anywhere from 0 to 5 of these little marks past 0. We usually like to park them between 2/10 and 3/10 past the tightest side. So let's check rod number 1, and we are right in that range. Rod number 2, almost exactly the same. Number 3, number 4, number 5, number 6. I gave these time to cool and then double checked, touched them up a little bit, so this is our finished size right here. That was number 7. Finally, number 8, right there as well. We're less than 2/10 variation. Realistically, we're close to about 1/10,000th of an inch variation in size across all 8 connecting rods, and we're perfectly in the middle of our tolerance range of basically being from 0 to 0.5 thousandths over 0 on that gauge, 2.3247 to 2.3252. We can come out, and that's kind of out towards the edge of the rod on this side. Flip it around and check the same kind of thing. So we're good and straight. We don't have any taper in the rod, meaning from this face to this face, it's all the same size. We don't have any hourglass shape where it would be tight in the middle of the rod and looser on the outsides. We also don't have a barrel where larger diameter in the center, tighter on the 2 edges. So I'm really happy with these. Resizing rods can be a monotonous process, but the satisfaction of finishing a set of rods with 10th precision is hard to beat. While the rods will get a final wash before being installed in the engine, I'm going to leave them together for now and rinse them with solvent, since we're going to be balancing these rods in the next video. Thanks for watching, and we'll see you next time.